Alright, hi and welcome back. We're going to start talking about muscles and actually how these muscle cells function. Um, so they're a little bit different. They're going to be a very unique looking cell, so I don't want you guys to get lost. These are cells that we're going to be talking about. And when we're talking about these structures, they're going to be at the super microscopic level. But so even though each individual structure that we'll talk about is very tiny and all by itself can exert very little force, when you put millions and millions and millions of them together, it's going to actually produce a very strong force, and that's what's going to allow us to lift very heavy objects. Okay, so we'll talk about how muscles work together as groups, what makes a difference between lifting something light like a pen or a piece of paper, and what allows you to then differentiate between that kind of force and then trying to pick up like a heavy table or luggage or couch or something like that. All right, so with that, let's get going. All right. One of the things that I really want to impress upon you is that muscles can only shorten, okay? So that they can only contract. So when we have movement really is from muscles contracting, and then the opposite movement is from opposite muscles contracting and other ones relaxing. So you might be thinking to yourself, well, all right, so if muscles contract, and again, I'm going to tell you this, like all the actions that you are going to do in your everyday life is due to the contraction and the shortening of muscles. So they can only pull on bones, right? But by muscles pulling on bones, this can result in an action that looks like a push to us, okay? So let me kind of break this down for you. So let's just take that example. Let's take a push, right? So clearly I'm moving something away from me. So how does something move away from you if it's muscles that are contracting? All right, well, let's look at this. If we start here, right, basically what's going to happen is that our arm, so let's just kind of take this arm, it's going to, ends up here. So what that means is the brachial area has to come in and the forearm area has to go out. So we end up right here. Okay, so kind of again, I guess maybe I'll turn this way. So this will come in and out. So the muscles that you're actually using are going to be pectoralis muscles, so in, and then triceps muscles, out. So those muscles are contracting, they're shortening to push. Now granted, when we push something, we don't go like over and then out. They work, you know, our brain allows very specific firing of these muscles, so we have a nice fluid movement, and when we get to the actual brain, we'll talk about how it does that. But again, it's like pectoralis muscles contracting, triceps muscles contracting. So that's what allows us to push, okay? But the muscles themselves are contracting. Okay, if you kind of keep that in mind for this upcoming practical, that muscles can only contract, it'll make your life a little bit easier when you're trying to memorize what their actions are. So if you know it's back here, and this muscle is going to contract, well, right, it's going to pull on those bones, so you just have to remember what that action is called, right? So it's going to extend your forearm, for example. All right. Hide me here. All right, so we're going to end up talking about is how muscles contract and relax. We'll talk a little bit about how what's actually happening down at that molecular level. And so here's just a microscopic image of the way, like a super zoomed in electron microscope image of the way our muscles look. So you'll see there are these alternating dark light bands. We'll talk about these structures here. You can see the mitochondria right in here. You can see what's known as sarcoplasmic reticulum and what are known as transverse tubules. And then we'll talk a little bit more about how they're actually arranged. Basically, they're going to be arranged like a cell is arranged in a group of cells, is arranged in a group, in a group, in a group, and it kind of like builds together like that. We'll get more specific in a second. Okay. Let's just review the different types of muscles. So we have 3 different types. The first one, and this is the one that we're going to be focusing in on this semester and in this lecture, we're going to be predominantly talking about skeletal muscles. So this will attach to either bone, so again, contracting your arm, moving your arm, leg, what have you, to skin, so what's allowing you to move your lips, make facial expressions, eyelids, stuff like that, or other fascia, other connective tissue. Okay. Skeletal muscle looks striped or striated. You have these alternating light-dark bands. We should have seen this underneath the microscope. And then it's voluntary. So you tell your arm to move. It doesn't just all of a sudden move on its own, right? So you tell it to contract, relax. So here's, of the 3 different muscle types here, this is skeletal muscle. Cardiac muscle, on the other hand, so that's the one in the middle, is also striped in appearance. So it'll have basically the same microscopic arrangement of fibers that you'll see in skeletal muscle. However, it is involuntary. So cardiac muscle, right, is our heart, and we don't think about our heart beating. It just does it. And we can't really control it, like beat faster, beat slower. It just does what it's going to do. These cells are also known as autorhythmic. They have built-in pacemakers. So if you were to reach into somebody's chest, or even in an animal's chest, pluck out their heart, it would keep beating. I mean, theoretically, it would stay beating. Like if you could put it into a fluid media that would supply it with nutrients and oxygen, it would simply keep going because it has its own pacemaker. And so then this last type of muscle tissue is smooth muscle. Classic place where we see this is in hair follicles in the skin. So I saw those erector pili muscle, for example. We'll find them in the walls of blood vessels, in the gastrointestinal tract, so stomach, intestines. They are not striped, so that means that the microscopic structure is going to be different than that of cardiac muscle and skeletal muscle. And these are also involuntary. You do not tell your stomach to churn food. You cannot tell your intestines to pass something along faster or slower. It just goes at its own pace. One of the other hallmarks of smooth muscle is it's tapered. It's what's known as spindle shaped. So it's thicker in the middle, and then it tapers out to the ends. Okay. Another thing just to bring to your attention, smooth muscle will have one nucleus. Usually it's centrally located. Cardiac muscle, each one of these cells, they'll have sort of a branching kind of pattern to them, but they also have one nucleus. While as skeletal muscles will be sort of cylindrical in shape, but they will actually have many nuclei. So that's another thing that differentiates these 3 from one another. So just talking about some of the functions of muscle tissue. So we've already mentioned that they produce body movement. They help stabilize your body position. So the fact that you are sitting upright is because muscles in your back and the back of your neck are contracting, keeping your head upright and sitting upright. If all of a sudden they were to relax, you would slump forward. They help regulate organ volumes. So for example, like in your blood vessels can contract, decreasing their volumes or expand. So this would be more the job of involuntary smooth muscle. They'll help move substances within the body. Similarly, like your heart helps move blood. Different muscles will help pump lymph throughout your body. Urine as well. So in the tubes that take urine from our kidneys down to our bladder, we have smooth muscle in helping move urine through. Air, our diaphragms, food, fluids, even sperm. So those tubes that take the sperm from the testes through the male reproductive system will also have smooth muscle in them. Oh, one last point, go back. Muscles will also produce heat. We know this. When you're cold, what do? You shiver, and the act will produce heat. You also know this, like if you're jogging or doing something really active, you start sweating because you've gotten hot because the muscles have produced heat. Okay. So some of the properties of muscle tissue that makes them unique. One, they are excitable. This means they are responding to chemicals released from nerve cells. Okay. They are conductive, meaning that that signal, they don't just respond to it, but they can send that signal over the length of their cell membrane. They contract. They shorten, and by shortening, they can generate force. They are extensible and elastic. We talked about this earlier in the semester. So extensible meaning that they can be stretched, and then elastic meaning that they snap back to their original shape. Remember, I gave you the example, the difference between gum and a rubber band. A gum is extensible. We're able to stretch it. However, if I held gum in my teeth and I pulled it away from my mouth, yes, it would stretch. However, if I let go, it would not snap back and hit me in the face. However, so gum is not elastic. However, it is extensible. A rubber band, on the other hand, if I held it in my teeth, pulled it out, it is extensible. If I let go, it would snap me in my face. It is also elastic. So I would not do that. All right. You'll often hear the term skeletal muscle cell. You'll hear them being referred to as fibers. They're synonymous with one another. So you'll either hear skeletal muscle cell, skeletal muscle fiber. You will have lots of connective tissue holding muscle cells together. Because they are producing so much force, you want to make sure that they're being held in place. They don't suddenly rip on you. They don't suddenly displace themselves or they bulge out. So we're going to have many different layers of connective tissue and wrapping and binding around them. Okay. So we have a superficial fascia, so that's the sort of very outside. That's loose connective tissue and some fat. We have deep fascia, so it's this dense, irregular connective tissue around the muscle. And then part of the muscle itself. So we'll have epimysium that's going to surround the whole muscle itself. Again, as I mentioned to you a little bit earlier, we're gonna package these cells in bundles, and those bundles are called fascicles. And surrounding each one of those, we have perimysium. And then even in between individual muscle cells, helping connect individual muscle cells together that are in that fascicle, we have endomysium. Okay, so we wrap it around an individual cell, help them stick together. Then we bundle them into like a bundle. We wrap that. We put many bundles together, and then we wrap that, and then we have these other connective tissue even on top of that. So lots and lots of connective tissue. Okay. So these epimysium, perimysium, endomysium, those are all going to extend beyond the muscle belly, so that's central, like the actual meaty part of the muscle, and that's what forms the actual tendon. Okay. And if you remember back, that'd be dense, regular connective tissue. All right. So I'm going to try to explain this image to you, and hopefully it won't confuse you. I kind of think of this image sort of as these Russian nesting dolls, right? So it's basically like there's something that looks like the thing before sitting inside of it, which looks like the thing before sitting inside, and so on and so forth. So let's just kind of take a look at this at this small level. I think it might be a little bit easier moving up. So if we take a look, this image, this whole image right here, it is basically this thing right here blown up. Okay, so we took this that's sticking out, blew it up, and that's this. And then one of these things, we've now extended that and we're looking at it. Okay, so this right here is a skeletal muscle cell. This thing is a muscle fiber. So in this image, this fascicle, this bundle, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 or so muscle fibers. Those are each muscle cells. And I know they don't look like what we naturally think of muscle, like cells looking like, right? They don't have that sort of bag of fluid kind of look to them. They are really weird looking, but they are cells. So again, this is a whole cell, and this cell is going to be made up of basically these little smaller bundles, and we call those smaller bundles myofibrils. Okay. So a myofibril, many of those will make up a muscle fiber. Right? And each one of these myofibrils is made up of tiny little filaments. Okay. So let me see. Maybe I'll start writing this on this slide. So let's see. Maybe this might be a little bit easier way for you guys to think of it. So filaments make up myofibrils, which then make up muscle fibers. And remember, that's just another word for the muscle cell. Okay? And then a bunch of these muscle cells, or myofibers, will make up a fascicle. Okay? So this is what this fascicle is. So then this fascicle here, so here, now we kind of go back to this image. So here's this fascicle that we're just looking at that was blown up. If you look here, we have several muscle fascicles in the entire muscle. Okay? So several fascicles will actually make up a skeletal skeletal muscle. Okay. So hopefully that makes sense to you. And again, remember this muscle fiber, each cell will be surrounded by connective tissue, that is endomysium. The fascicle will be surrounded by connective tissue, that is perimysium. And then the entire skeletal muscle will be surrounded by connective tissue, that is epimysium. Okay. And then the epi, peri, endo will all extend past the muscle as the tendon. So hopefully that makes sense to you. Here's an image of corned beef, actually. So when you take a look at any of the meat that you might eat at the grocery store, and hopefully you can see this well on your screen, can you see how you have this little bundle here? There's a bundle. There's a bundle. Can you see all those little bundles? Okay, those bundles, that's a fascicle. That's what that is. So in one of these bundles are a whole bunch of muscle cells. So that's what we're talking about. And around the outside, you can see all that fat and that grizzle. That's that superficial fascia that has connective tissue and fat in it. Okay. Right. So each skeletal muscle will have a nerve, artery, and at least 2 veins. The neurons, the nerves that are supplying the muscle cells, they'll supply several muscle cells, so they don't just supply one. So here you can see here these motor neurons. Here's this green one. It's supplying those 3 muscle cells, and this purple one is supplying those 2. Okay. Where the muscle and the nerve meet, that junction, that union, we don't call it a joint because it's not bone, but we call that a neuromuscular junction. Okay, so that's where the 2 basically are. They're not technically in physical contact, but that's where they are sort of joining together. We'll take a look in a few slides. You'll get a better idea of what I mean by that. Okay. Lots of blood. I think we know that you cut a muscle, it bleeds. Muscles need lots of nutrients, lots of oxygen. They're very metabolically active. They're doing lots of work. Okay. Okay. So one of the things with this image that I kind of wanted to show you, so again, what we're looking at here is going to be a single muscle cell, right? So right in this image, the single muscle cell. And what you're seeing, basically, so here are these myofibrils, right? So you can see this myofibril. So each one of these, right in here, you can see the mitochondria that we all know and love, that we can all recognize, we find inside cells. Do you guys remember endoplasmic reticulum from inside cells? Well, we have a very specialized form of that endoplasmic reticulum, and because it's specialized and it's only found in muscles, we call it sarcoplasmic reticulum. Okay, so instead of endo, it's sarco. And we're going to see in a slide or two that we have a lot of terms that are sarco something or other when we're referring to muscles. Okay. So we have that endoplasmic reticulum. Again, it's kind of specialized looking, but same kind of thing you would find inside a cell. There's nucleus. Again, skeletal muscles have multiple nuclei. Same thing you would find inside of a cell. So remember all those microtubules, microfilaments, all that kind of stuff that we talked about. So these are those these are these microfilaments that we had mentioned back in the cell too. They're just specially organized into these myofibril structures. And basically what's going to happen is we're going to have an electrical signal that basically washes over the cell membrane of a muscle cell, and it'll travel down what are known as T-tubules, these transverse tubules. And as that electrical signal kind of goes down the length of these transverse tubules, it's going to stimulate that sarcoplasmic reticulum to release calcium, and it's going to be that release of calcium that's going to instigate the contraction of a muscle. And we'll go over all of that and exactly what happens in a few slides. So again, I just kind of brought up this regular cell, I guess not a regular cell, but like our everyday concept of what a cell looks like. And I just really want to remind you that even though it looks weird, it's basically the same thing. We do, again, have a lot of the same components to it. They're just specially arranged in that muscle cell because it has such a specialized function. Okay. So let's just do a vocabulary check real fast, and let me just give you some definitions here, because this will be one of those things where with muscle it's a little bit tricky because we're going to hear a lot of this, like a lot of the words sound very similar. All right, so this term sarcolemma, because again that cell membrane is going to be a little bit specialized in muscle cells, so it can conduct electricity. And in all honesty, you know this because you know if you tase someone, right, that like they kind of convulse, it's because that electrical signal from the tasers is washing over your muscle cells, causing them to contract, and in this case, uncontrollably, right? So anyway, so because it can do that, skeletal muscle cell, the cell membrane specialized, so it gets a special name. So the sarcolemma is simply the cell membrane. In a muscle cell. Okay? The sarcoplasm is simply the cytoplasm. We don't call it cytoplasm, we call it sarcoplasm. We don't call it cell membrane, we call it sarcolemma. I mentioned sarcoplasmic reticulum to you already. So that's the same thing as endoplasmic reticulum. And a sarcomere is basically the functional unit in a muscle cell. Okay. And then here I have the different terms. Muscle cell is the same thing as a myofiber, is the same thing as a muscle fiber. Okay. Do not confuse this term. This is not the same, does not equal myofibril that we talked about before. Myofibrils make up myofibers. Okay, so don't confuse them, they're not the same. All right, I'm gonna stop there and then we will pick up from the following PowerPoint on our next video. As always, please let me know if you have any questions on this material. Okay, see you next video.